To ensure that your IES wasn't damaged during transit, as well as ready for deployment, the pre-launch checks should be performed when you first receive your IES shipment and also conducted a few days before deployment. This video will guide you through items 1 through 8 on the IES Prelaunch Prep Checklist. Locate the user's disk flash drive in a folder underneath the IES device. For deliveries with multiple devices, documentation is located in the lowest serial number drum in your delivery. Let's begin by filling out Item 1 on the Pre-Launch Prep Checklist. For more detailed information on each item, consult the given references. From the user's disk flash drive, copy the motocross application and help file to a convenient location on the laptop that will be communicating with your IES device. Then open Motocross, select Transfer, Capture Text, and Start. Give your file the name that matches your IES serial number and _1. Number each time you turn on your IES and perform tests. This bookkeeping can help if you run into problems and need to consult with a URI technician. When prompted, choose Overwrite for new files and Append to previous files. Select Yes to include buffer text, which will include the printed menu between selected commands. Note the capture is on, and that the file will be located in the Motocross folder. To communicate with your IES, first locate the external communications cable and the USB to serial converter. Remove the yellow external connector plug. Replace this with the external communications cable and attach the supplied USB serial converter. Plug this into your computer. Check that Motocross is connected to the correct serial port by going to File, Communication Settings. Then go to Device Manager, and in the Ports drop-down menu, locate USB serial port. For this example, we will change our port to 5. Always set the protocol for baud rate 9600, parity none, data bits 8, stop bits 1, flow control none. The altimeter reading should be between the green and red dots. The IES is vacuum sealed to ensure that there are no leaks and that the hemispheres remain together when shipped in low pressure conditions on airplanes. If your altimeter reading is near the red, note the ambient temperature and then place the IES in a warmer room and allow it to equilibrate. This should cause the reading to move counterclockwise towards green, ensuring vacuum has not been lost. Generally, the reading should be at the green dot. If the arrow moves counterclockwise below 10,000 feet without a warming in ambient temperature, this indicates a loss of vacuum, and the launch should be aborted and the IES resealed. To turn on the IES, insert the red external connector plug. These red and yellow plugs should arrive pre-greased, and the coating should be thin and shiny. After the red connector has been plugged in, the IES banner should appear on your screen. When prompted, press the spacebar to enter the menu mode. If you fail to press the spacebar within 10 seconds, simply unplug the on-off connector, wait 3 to 5 seconds, and reinsert the on-off connector. Scroll back up and note that the banner screen matches the correct serial number on the outside of your IES hard hat. Write down the version of IES firmware, which is month, day, year. Note any optional sensors that should be installed. This will vary for each user. Note that as a battery saving measure, after 10 minutes of inactivity in any menu mode, the IES will go to sleep. It will appear as though your IES is no longer responding. Simply reset by removing the red plug, waiting 3 to 5 seconds, and plugging it back in. If you would like to keep the IES from falling asleep during testing and setup, occasionally press the spacebar to refresh the menu view, and this will also reset the 10 minutes you have before the IES enters sleep mode. In normal operation under the ocean, the IES sends a 12 kHz ping and then listens for a 12 kHz return ping that is reflected off the ocean surface in order to calculate travel time. When testing the IES's listening and travel time calculating capabilities on land, the echo box acts as our simulated surface by listening for the IES's ping and giving a 12 kHz reply in the expected amount of time set by the delay knobs. Let's give an overview of the front panel. First, the frequency select. Travel times to the surface are always probed in 12 kHz signals. The 12.5 kHz frequency is important for receiving acoustic commands from the deck box and is discussed in the next section. The trigger select. Always switch it to mic for this test. This is both the speaker and the microphone. Delay dial should be set to 8 seconds. The 0.1 bob should be set to 0. No adjustment is needed for the output level. The signal is always at maximum strength when the speaker or mic is plugged in. Set the microphone of the echo box near the transducer and turn on the echo box. Often placing the echo box on the ground with the microphone adjacent to the transducer will yield better results. In the motocross window, from the main menu, select A, Self-Test menu, and B, Travel Time Test, 12 kHz. Compare your travel time to the delay set on your box. The echo box is not a precision instrument, but it does well for this check and should usually be within 0.01 seconds. If you receive a no echo default TT report, this indicates that the IES did not hear a reply from the echo box within the default window. If this is the case, check the following. First, is the box close enough to the transducer? Adjust the microphone placement and rerun the test. Also check, is the delay time correct? It should be 8 seconds. Check that the correct frequency is set, 12 kHz. And also, is the trigger set to mic? Finally, is the box on or is the battery still working? The battery is functioning properly when the red light briefly illuminates when flicked on. If you're still having trouble, check the default settings on your IES. Do this by going to the main menu, selecting C, Mission Setup and Start, and G for Go. When prompted, select N for No. Scroll back up. Check the estimated water depth, 6,000 meters. Acoustic lockout, 7.2 seconds, and the level should be at 197 decibels. A water depth of 6,000 meters will produce the loudest ping for this in-air test. Once in the ocean, the only way to communicate with the IES device is through the use of acoustic commands from an acoustic deck unit programmed with a set of IES acoustic commands. These commands are a set of alternating 12 and 12.5 kHz pings that the IES converts to control functions for: locating a deployed IES, releasing it from the seafloor, provide tracking signals during deployment and recovery, initiate data telemetry, and also to disable transpond and telemetry modes. To test whether the IES can hear the 12.5 kHz frequency, set the frequency switch to 12.5 kHz, and in the motocross window from the main menu, select Self-Test menu, Travel Time Test 12.5 kHz. Compare the travel time delay set on the box to that which you recorded. We now have confidence that the IES will be able to hear the alternating 12 and 12.5 kHz commands before we deploy it in the ocean. Set up the IES with the transducer facing up or down, but mark which direction. The pressure measurement is most accurate with the transducer up, but at room temperature and pressure, this check is very approximate. The motocross window, from the main menu, select Self-Test. D, Pressure Sensor Test, single PT measurement pair. This measurement takes about 40 seconds. Compare your results for the Peros temperature and pressure to the ambient temperature and barometric pressure. Make sure they are reasonable. This ensures the correct coefficients are programmed. functionality test ensures that the IES is able to charge and generate a ping. Since the acoustic transducer does not couple its power nearly as well in air as it does in water, a range of values between 100 and 650 watts is accepted. From the main menu, select Self-Test Menu, G, Output Power Test. Enter the value 197. The IES charges and then should give a ping. Record the power on your checklist. While still in the Self-Test menu, select S, System Battery Refresh and Test. This test is a series of 10 pings of increasing volume, followed by 10 pings of 197 decibels. This test exercises or depassivates the lithium batteries. Depassivation consists of placing a resistive load or a constant load on a cell for a short period of time. The discharge of the battery removes the buildup of lithium chloride or passivation layer on the lithium electrode, thereby lowering the internal resistance of the cell. This depassivation needs to occur when the batteries have been sitting for many weeks or exposed to high temperatures greater than 30 degrees Celsius. Write down the average charge time. The value is not critical. Between 1 and 3 seconds is merely a diagnostic indicator that the batteries are healthy. If the test does not pass, continue to burn off the lithium chloride layer by running the test several times. If the test fails 7 or 8 times, this may indicate a problem.